All right, today we're going to use some angle bisectors. We're going to start out with this angle BAC, and then we're going to bisect it. We're going to talk about a few things, and then after that, we are actually going to go and do the angle bisectors inside of a circle. So we'll talk about this here in a second. But now we know if we have a ray AD, all right, this is AD, and we know that it bisects BAC. That means these angles are congruent. And then we know a few other things. That this is a 90 degrees and this is a 90 degrees. All right, then we know we can say that BD is congruent to DC. All right, we use this to kind of just figure out some problems we'll have. Like for instance, this is 2x, this is 12. So we know they're equal, so 2x equals 12 divided by 2, x equals 6. So that's kind of where we're going to use it. It kind of sets us up for the next thing that we do. That's an angle bisector. You should have had a video watching on how to construct angle bisectors with your protractor and compass, and so you should be good there. All right, so what I've created here is we started with the blue triangle, and I just kind of guessed at this being the angle bisectors here. All right, so we're going to say that these are congruent. Basically, it cuts those angles in half. All right, so when we do that, there's a few things that we can say. All right, so these are the angle bisectors. And this creates a point where they meet up. This is called an in-center. All right, so that's the in-center of our triangle. All right, so now that we know where they kind of meet at, we're going to kind of shrink these in a little bit. All right, and that in-center is actually a very nice point. This in-center, all right, that we can see there, I kind of took those in just so we could see, is equidistant from the 90 degree angle. So we can have all these 90 degree angles here. The shortest distance between 2 points is a straight line. So here at this 90 degrees, we know that these are all the same. Now these don't necessarily match up with the angle bisectors. All right, it kind of looks like it does here, but it doesn't have to. All right, so these 90 degree angles we know is equidistant from the side of the triangle, that in the center. The way that we know this is if you get a circle and you start your circle at the in center, and it's going to be off a little bit just because it's not exact, but basically those blue lines that I drew represent the radius of a circle. So it's off by a little bit, but here, from here to here is a radius. From here to here is a radius, and from here to here is a radius. So that's kind of how we have it coming up, is we know, all right, we're going to use those right triangles, and then we're going to use some Pythagorean theorem and so on and so forth. So if I know, let me get rid of some of this stuff, this circle. If I know that, for instance, this side here is 3, this side here is 5, I can find out that this side here is 4 by doing 3 squared plus x squared equals 5 squared. X squared equals 16, and then x equals 4. And so we can kind of go from there. So we're going to be using those right triangles inside. Once we have our angle bisectors, then we can go that they're equal distant. That in the center is equal distant to the side of the triangle, and then that creates that right triangle that we're